Hello everyone and welcome to another Fusion 360 Live. My name is Brad Tallis from Autodesk. On the keyboards I have my friend Angelo. He'll be answering the chat questions for you. We're going to continue on with the miter saw project. We're going to be focusing on this sheet metal part today. We're not going to do this little slot right here. We're going to do that at a later point with some cool tips and tricks. And again, in the description of the YouTube video, I have my outline, I have a drawing, and I also have the image of the decal we'll be adding. So let's dive right in. I'm actually going to start out with something that you guys noticed on my last live stream when we created this center tube. I'm going to go ahead and edit that feature. If you remember correctly, I did a two-sided thin extrude, and because I was rushing, I made a mistake, and hopefully you guys can see this. A couple of you pointed this out. I typed in the wall thickness of 1.5, but notice down here on side 2, it defaulted to 1 millimeter, and so there's actually different thicknesses going in one direction and a different thickness going in the other direction. And some of you asked, how come you just didn't do a symmetric extrude? And the reason for that is, you'll notice when I switch to symmetric, that it says distance or all. And if I go all, it goes all the way through. So there isn't a two object in symmetric. So that's why I ended up doing the two sides. So this allows me to specify different distances for either direction. And here I can say to object. So for example, click here and it's only going to extrude to that object, but I just need to make sure with the thin wall or the thin extrude that I make sure I type in my correct wall thickness. So good catch for those of you that noticed that. We are going to be creating this part here. It's a sheet metal part. I'm going to basically walk through step by step. I've included the drawing, and you'll notice the drawing is going to look, hopefully it'll come up, a little complicated. Yeah, there it is. But this is a typical sheet metal drawing. Here's the flat layout. And then you'll notice these numbers like 4, 5, 7, 9, etc. These are bend identifiers. And you can see I have a bend table in the upper left corner. So it tells you which bend. So let's just pick on bend number 5, for example. Bends down at an angle of 48 degrees with the default radius of 2.5. And this will make more sense as we go through. You'll also notice that there's some sheet metal tabs in here that these get welded on. Basically what we're going to do here is make it so we can put some legs. This is basically what supports the legs for the whole assembly. Okay, so let's continue from where we left off last week, which was we created these end caps, the tubes, the center tube, etc. And so now I want to start creating, the ability to have the legs on here. So we're going to, let's activate the end cap assembly. Okay. I need to make a change that I forgot to do on the last live stream. So I need to modify this plastic, this black plastic part. So I'm going to go ahead and activate this assembly. And then let's just do the end cap cover. That's all I'm really concerned about right now. What I want to do is basically remove, in fact, let me get rid of the end cap. Let me just turn off these tubes here so you can kind of see. I want to remove this whole section right here because the sheet metal part is going to be inside of here. So here's a neat little trick. So I'm in my end cap cover. So these are all the features that have to do with my end cap cover. And I'm just going to come in here and say extrude. And if I go in the negative direction, you can see that it's going to cut that geometry away. Okay, so I'm going to specify to object, and I'll just pick this top face. It's going to say cut. We'll say OK. And now you'll see like we have this end cap, this metal part, and then this plastic part kind of fits over that a little bit. Okay, I'm going to go to my higher level assembly, which in this case is my table assembly. Activate that, and I'm going to create a new sheet metal component. So to do that, I'm going to come over here to my sheet metal tab. So it's kind of across the top, and you'll see create new component. Now what this does is it brings up a new component, but by default it usually is set to standard, but because we said we're in sheet metal and we're creating a new component, it's going to create a new sheet metal component. I can give it a name. Let's just call this leg support plate. Okay, and then you'll notice the thing that's a little bit different is it has these sheet metal rules. And I can pick, and you'll notice I have some ones that I've actually created in here, and I'm not going to go into too much detail about how I created these. I have a different live stream just on sheet metal where I talk about this. But you can see we've got steel, stainless steel, aluminum in millimeters, and then steel, stainless steel, aluminum in inch. And since this is metric, we're going to do the stainless steel millimeters. If I expand that open, I can see it's 2.5 millimeters in thickness, 44% K factor, what my miter, rip, or seam gap is going to be. It's the same as the thickness, etc. I could check out what my bend conditions are going to be, like straight, for example. I can also see what my corner conditions would be, so like trim to bend, etc. I'm not going to go into too much detail there, but we're basically just specifying what kind of material do we want to use. So I'm going to say stainless steel, and you'll notice I get a new feature underneath my table assembly, and the icon looks kind of like a piece of folded metal. So this is our leg support plate. Okay, so I'm going to now create a sketch on the inside of the end cap cover. So let's turn off the end cap. This is the cover. So basically I know that the sheet metal part is going to kind of be inside this. So I'm going to click on this face and create a sketch. And let's turn off the other end cap assembly. Center tube. Let's just turn off anything we don't really need right now. Okay. Kind of simplify some things here. I'm going to grab some information. So I'm going to project this inside face. So P for project. We'll project that. I say okay, and you can see we get these projected lines, and then I'm going to start to kind of draw the basic shape of what I want this part to look like. So I'm just going to do something like this, like so. Kind of a trapezoidal shape. I didn't worry about dimensions or anything like that right now. What I want to do is make sure that it's equal. So I'm going to draw a vertical construction line. So I'm in my line command, and I'm going to switch to construction. Now watch what happens here. So as I hover over this line, you can see it's going to snap to it coincidentally, or coincident. But as I move across, you'll see it kind of snap to that little triangle. Well, that's the midpoint. So I'm going to click there, and I'm going to do the same thing here. I'm going to come across, and you'll notice there's no triangle there. So I'm going to keep moving across. There's the triangle there. So that's the midpoint of that line. Now you'll notice that line is not vertical, so let's go ahead and add a vertical constraint, and you can kind of see how now the trapezoid is more symmetric, right? The middle of this line is in line with the middle of that line. And because I used a construction line, it doesn't affect my profile, it doesn't split it in half or anything like that. Okay. Notice we're in millimeters. This is what we used last time when we were doing this design. I wanted to show another neat little trick. I'm going to dimension this line right here, and we can see that it's in millimeters. Hopefully you know this, but you don't have to switch units if you want to use a different unit. So for example, I want this to be 4 inches. So I'm going to type in 4IN for 4 inch. I'm going to hit enter. And you'll notice it still displays it as millimeters. But if I were to edit that dimension, I can see that I typed in 4IN. I could type in 4 cm for centimeters, for example. You could even do something like 4IN plus, oops, yeah, plus 5 millimeters. So you can do different commands in here. So inches and millimeters, right? Pretty powerful, and I really like this, especially if I know, for example, I measured this and it was exactly 4 inches, even though the rest of the design was in millimeters. Maybe the company that designed this part that they used designed it in inches, and so all the holes are inch, sizes, all the lengths are inch sizes, etc. So let's do the same thing. I'm going to dimension this line here, and I'm going to type in 10.25, so 10 1/4 IN. And you'll see that that updated accordingly. Okay, so kind of a cool little trick. Hopefully you knew about that, but I use that one actually quite often. Okay, I'm kind of done with my sketch. I could draw a line straight across, but it's already projected, so I don't need to in that case. I'm going to say Finish Sketch. And because this was a construction line, you'll notice it doesn't split my profile in half. But I'm going to select this profile, and then you'll notice we can create a flange. Now, a lot of people think a flange is like a bend or whatever, and it is, but you also use this command to start, to create your actual sheet metal part. So I'm going to say flange, and it instantly, oops, too far, instantly gives us a preview of what that's going to look like. So we can kind of see that that sheet metal part is on this face, or in line with that face, and it's extruding to the right. And that's this thickness. If I say go to side 2, you're going to see it's going to extrude the other direction, which obviously we don't want because it would cut into our part. So you can switch which side, or you could even say symmetric, and it'll extrude equal distance both directions. But this is going to create our sheet metal part. Now we're going to basically just modify this sheet metal part. So I want to create a bend right here. So I'm going to click on this edge, right mouse click, okay? And you'll notice that the flange command is at about 4 o'clock. Or I could repeat by dragging straight up or pointing at 12 o'clock. So I could grab it from the menu up here, or I could just pre-select an edge like I did here. Just pre-select an edge, right click, and there's my flange command. Now we're going to dive deeper into all of these options as we're going through, but I like to personally start to drag to kind of visually see what the result is going to look like. And so we can see some interesting things happen. Even though I clicked this edge here, it's kind of extending up above that. And that is this bend position. Now, just like a lot of things in Fusion, Fusion remembers the last options that you used, and I did an adjacent down the road. So I don't want it to be adjacent. I want it to be inside. I'm going to go through all of these and show you what they do, but notice what it's doing now. Okay, I'm getting the result like I would expect it to be. So bend position, let me kind of look at it from the side here. So inside, outside. So you can kind of think of like, here's that line, and we're bending to the outside of it. Here's that line, we're bending to the inside of it. So those are the two different options right there. So you can kind of imagine this line, I'm trying to hover over right here, that's the original line. So we're bending to the outside, or we're bending to the inside. And then you have adjacent, and that basically is the bend starts at the line, okay? So it kind of makes it even taller. And then we have tangent, and with a 90 degree, it really doesn't matter in this case. In fact, you can kind of see the icon shows it more at like a 45 degree or whatever. But I'm gonna set it to inside, because I want it to basically follow my existing plastic part. Now, it's also asking for a height. What is the height of this flange? Now I could type in a number, but check this out. I can hover over this plastic part, this face right here, and go ahead and click, and it's gonna extrude or create that flange to that distance. And in this case, it's 17 millimeters, which is pretty cool. I didn't have to measure or do anything like that. Now, close your eyes really quick. If you if you were to do this and click on this face, and you'll notice that it doesn't extrude to that face, that is this height datum option. Okay. And again, I'm not going to go into too much detail here. I have a really cool live stream where I basically wrap a sheet metal part around a cube and I show what all of these options are. But you can see we have inner faces, outer faces, and tangent to bend. So basically what it's saying is if I say inner faces, it's going 17 millimeters from this face to this face here. So that's my height. So 17 millimeters from this, it's kind of hard to highlight, this inside face to that top of that flange. If I were to say outer faces, it's 17 millimeters from this outer face to the top of the flange. And that's why you see pretty much the thickness of our material is missing right there. It's because it's over here. So I obviously want to make sure that is set to inner faces. So I know it's 17 millimeters is the height of the flange. And I'm just going to go ahead and say okay. Actually, I lied. In this case, I'm going to change one more option in here. You can see this full edge. So it's bending that whole edge. And if I click this little down arrow, you'll notice we get other options. Symmetric, two sides, two offset. We're going to be using these. And I'm going to use the symmetric right now. And you'll see these little arrows appear. And if I start to drag those arrows, you're going to see something interesting happen. It still creates my 17 millimeter flange, but now I have a bend relief, and it does not go the whole length of the edge. In fact, it's symmetric. You can kind of see the black line stops right there, and this flange is 56.65 millimeters long right now. Instead of the whole edge, I want to give it a little bit of clearance, and you'll see why as we start bending and folding and unfolding. So I'm going to set this to 92, and you'll see it creates a little bit of a relief right here, and this flange fits inside my plastic part. If I said full edge, it's hard to see. Whoop, man, my zoom is really touchy. It's kind of hard to see, but the bend is actually clashing with our plastic part. As you bend this material over, you can kind of see the preview of how it's going to deform, but it's clashing. And so it actually wouldn't fit. So I could come in here and say, give me a symmetric, and now it's kind of moving that flange in a little bit, and by doing that, it's giving us the clearance that we need. So just another neat little tip. Definitely kind of look as you're designing your parts. Maybe you do an interference check every so often. Make sure things aren't clashing with each other. So I'm going to say, okay, I know that was a lot of talking for one little flange, but you'll see this will make more sense as we go along. Okay, now I want to maybe add those, what I call the wings. So I'm going to click on this edge here and say flange. I'm going to start to drag, and you'll see it'll actually take that edge, create the corner relief if need be. In fact, I'm going to go ahead and do both edges. So I'm going to hold down my control key and select both edges at the same time. So you can kind of see how we're doing that. And again, I'm using information from the drawing. So this is 130 millimeters. I'll say, I'll just kind of confirm. I'm going to probably leave a lot of this stuff default. Inner faces, because I want this to be 130 from that inside face. I'm just going to go ahead and say okay. Now you'll notice an option here that says miter option, and it's checked. Basically what that means is, like, if I were to add another flange on the top here along this edge and over here, it would actually create the corner reliefs for me automatically. Not the corner reliefs, but the miter corners for me. In this example, there isn't really the need for it. In fact, if I turn it off, you'll notice nothing happens. but I'm just going to leave it on by default since that's what Fusion recommended. So I'm going to go ahead and say OK. So 130 at the angle of 90, we'll say OK. And we just created these flanges. One of the things I really like about Fusion sheet metal is we can do regular modeling commands. So for example, if I click this edge and right mouse click, you can see fillet and chamfer. I don't have to switch back to the solid tab. In fact, I can even come in here and you'll see, for example, commands like hole and mirror. And over here, you'll see, fillet and chamfer. So they exist in sheet metal and in solid. So I'm going to come in here and say fillet. I'm going to select both edges at the same time. And move out a little bit. I'm going to start to drag so you can kind of see what's going to happen here, but we're going to round over these edges like so. And according to the drawing, 80 millimeter fillet. We'll say OK. And I now have these little wings. Now, as we're going through this, one of the tips that I recommend, especially with sheet metal, is after you do 2 or 3 steps, try and unfold. And if it can't unfold, there's something wrong with the model. So like things are going to clash with each other. So what I typically do is I come into modify and I'm going to say unfold. And it says, what's the stationary entity? What's the piece that's going to lay flat? So I'm going to just click on that face there. And you can see it kind of highlights some stuff in green. And I could pick on any of these and unfold them one at a time. Okay. Or I could just come in here and say unfold all bends. And this is what I typically do. Now, what I mean by doing this is, like, for example, and I'm not going to do it right now, but if this, for whatever reason, this tab or whatever came out too far and it actually intersected with this, it would error out. So I usually do an unfold. I don't even say OK. I just hit cancel and it puts it back. If you were to say unfold all bends, stationary entity, and I say OK, you'll see it actually puts an unfold feature in your timeline. And then you'll also notice you get this refold faces. So I could click on refold faces, but that just added 2 features into my timeline that I really don't need. So that's why I usually just do an unfold and cancel out. So stationary, unfold all bends, that looks great. I hit cancel, nothing went into my timeline. Okay, moving on. Hopefully if you guys have any questions or comments, you're putting them into the questions for Angelo. If you see something you didn't know about, throw that in there. We always read the comments and the questions, and if we like to know what you guys are learning, other topics you want to see, etc. So definitely put them in the chat and or in the comments of the video after the video is posted. Okay, let's go ahead and continue on. I'm going to let me jump to this guy so we can kind of see what we're going to do next. So we're going to be creating this little feature you see here, and it actually kind of looks like, it has a little bit of material here, and then it has this part right here. And what's going to happen down the road is we're going to have some legs that come down and are basically right between this little tab right here. Okay, so how would I do something like this? Well, I'm going to click on this edge, right mouse click, and do the flange command. And like I shown before, I like to start to drag to visually see what that's going to look like. Okay. So I want to make this a pretty short flange. So I'm going to do like 5.5 millimeters. So we're just adding a little bit of material here for strength. I'm going to leave it default, interfaces. Now bend position, let's take a look at this. So we can kind of see where it's at right now. So it's on the inside. Let's go to outside, and you can see how it's now kind of pushed down below. Let's go to adjacent, and now you can see how basically the bend is starting where that edge was. So inside, you can see that that bend is basically where that edge was. So those are the kind of these options here. So I'm going to switch it to adjacent because I want it to stick down below the part a little bit, like so. That way I know I have clearance as I'm manufacturing this part. So I'll say OK. And I love the fact that, you know, Fusion creates the deformed face for you, so you kind of see what it's going to look like as this thing is bent. That little face right there. Pretty cool. Okay, so I now have this little lip. Now, how would I go about adding this? Now, some people would say, okay, now you can put a sketch on this blue face, draw that profile, and extrude it or add it to that lip. And you could do that. But here's a neat little tip. I'm going to click on this edge, create a flange, and I'm going to start to drag. Now you'll notice I get an interesting result. It's extruding down. Well, here's where this angle comes into play. I can grab this guy and rotate this lip until it's at 0 degrees. So we're basically just adding extra material to it. In fact, I'm going to leave it down here for now, just so you can kind of see what's going to happen here. The next thing I want to do is, instead of going the whole length, we're going to do another symmetric. And I'm going to start to drag just so I can visually see what that's going to look like. And the distance for this, and again, symmetric is basically the half the distance. So right now it's showing like 98 millimeters. So this is almost 200 millimeters wide right now. So I want to know what this half distance is. So that is going to be 82 millimeters. So we can see how that instantly updates our preview. We'll make the height be 10 millimeters in this case. Excuse me. And now I can either type in or I can drag. So I'm going to drag this to 0. And we can see how it basically added that extra little symmetric tab. And when it gets to 0, it doesn't have to do a bend relief, so you'll actually see the bend reliefs kind of disappear once I fold that back to 0. So just a neat little tip just to add extra material. You can use the flange command, believe it or not, and use some of these edge options to help you out. Again, I'm just going to leave these default. They don't really matter in this case. I'll say OK. And we've now added that little, strengthening rib, or flange, I should say, right here. And then we've added some extra material. I don't like sharp corners, so let's go ahead and fillet. In fact, we're going to fillet a bunch of edges. So I'm going to just zoom up and select these two. And I want to soften these edges here. So I'm going to pick that edge and making sure I grab the right edge, because I can actually grab an edge off a different part. So I want to make sure I grab that edge there. Start to drag so you can kind of visually see what's going to happen. We're rounding over all of these corners. In fact, I think the 10 millimeter fillet. I'll say OK. And like I showed before, now that we've done some stuff, just really quick, I'm going to come in here and say unfold. Unfold all bends is the last thing I checked, and sure enough, that unfolds. So we know we're good. Kind of just a cool progress check, just to make sure everything's working correctly. Okay. The next thing we're going to do is this weird feature here, and I wish I could show you on the actual, actually, I'll rotate my camera here. I actually have the unit right there, but I couldn't take the part off to show you guys. But it actually kind of bends around the tube. In fact, if I come in here and let's turn on this tube, you can kind of see how this metal is just kind of bent around it. It kind of helps, pinch it in place, I guess, between the two tubes. So how would we do something like this? So what I'm going to do, and because it's the same on both sides, I'm only going to do it on one side, and then we'll do some cool tricks here in just a little bit. Okay, give me half a second here. Angelo said, check the Google Doc for some questions. Um, okay, so somebody asked, are you guys planning on doing advanced surfacing anytime soon? Actually, great question. Let me, whoops, I got out of. One of my cohorts in Denver, Jason Lickman, is actually talking about doing an advanced surfacing live stream. I also have somebody on my team that does a lot of industrial design. I've talked him into doing a live stream. When, I'm not 100% sure yet, but that is on the roadmap. So definitely keep your eye out for that. So let me jump back to the questions. Okay, can we make sheet metal rules default to inch mode? So again, I'm not going to spend too much time. Let me make sure great question, by the way. Make sure I'm sharing my screen. So in sheet metal rules, you can create your own rules, and you could remove these. You could make them all inch if you wanted to. Even though I'm in millimeters, I could have it just show inch rules, etc. So in fact, you'll notice I even have one in here called cardboard. So yes, you can make your own rules. You can't really make it like default, I think, to a particular setting. If I go into my preferences real quick, now I'm curious. I know you can for, yeah, so you can for like electronics, manufacturing, but you'll notice you don't see one here for sheet metal. So it's just going to use whatever your default design units are. That's what it's going to use. So Angelo, thanks for pointing that out. I need to remember to bring that Google Doc up more often. Okay, let's keep going here. So we are going to start creating that lip. So I typically pick like the inside edge, and let me show you what I mean by this. I'm gonna click that inside edge and say flange, and if I start to drag, you're gonna see it's kind of like bending that inside edge. Now we do have the option to flip the direction. Okay, so even though by default it's coming in this direction, you can click on flip and it flips the other direction. If I had clicked on this edge and I say flange, you'll notice by default it wants to go that way. If I say flip, now it flips to the inside. So again, you do have some flexibility there. I just like to pick kind of the edge that I think is going to be bent. That's just me. So I'm going to say flange, and I'm going to start to bend. Now I'm going to purposely make a mistake here. So you'll notice what's going on back here. Now it actually looks like we have enough clearance. But let's just see what happens. I'm kind of curious. I'm going to go ahead and say okay. I'm going to save just since I haven't recently. And let's go ahead and unfold this. How many of you think it's going to unfold? So I'm going to click on that. Unfold all bends. Notice, okay didn't come up, and I got an error message. Collisions found while unfolding. Cannot unfold. That's how smart this software is. It says you can't unfold that. However, let's try this. Instead of unfolding all bends, could I unfold this one first and then unfold that one? And we have clearance, and then I can unfold this one. That is where the issue is. And so let's do that again. I unfold that one. I unfold that one. Okay. Now think about what would happen when we unfold this wing. It's going to kind of rotate around, and it's going to clash with this feature right there. And that is why it can't unfold. Okay? So that's why I do this little unfold test every so often to make sure, okay, this looks fine to me, but manufacturer-wise, you wouldn't be able to do that. So instead, we're going to instead of having to do a full edge, in fact, I'm going to turn on, let's turn on the tube just so we can kind of see what this looks like. You can kind of see where the tube is. I'm going to turn this on to 2 offset. What that allows me to do is I can do an offset in one direction a certain distance. I can do an offset on the other side a certain distance. Okay. Now in that case I don't really need to, so I'm going to go ahead and clear that. So let me do, oops, didn't mean to do that. Let me change this to 2 offset, and I'm going to start to drag this reference here. And I want to make sure I get enough clearance. So obviously 24 is enough. Let's kind of look. So I'm going to say, you know, to keep like an even number, I'm going to do maybe like 20. So I'm going to come in here and say minus 20. And now that lip or that flange isn't tucked underneath that other flap. Okay. Then for the height, you'll notice as I drag this height number changes. Let's set that to 20 millimeters. And not sure why my tube turned off. What I want to do now is kind of have it to start to match. And let's grab this guy and start to rotate, and you can kind of see, I love this kind of this preview. In fact, I could look orthographic like so and start to drag, you know, until I get something that looks pretty good. In this case, I'm going to do somewhere around like 40, looks like 40. So let's just come in here and say 40. I could play with some of these bend positions. So if I said inside, that kind of drops it down. If I say outside, or if I say adjacent, you can kind of see those different options there. Height datum really, you know, again, it's in the interfaces, so this is that 20 millimeters basically from here to here. So I'm going to go ahead and just say OK, and oops, man, I hate that when it zooms out so fast. It's because this tube is really long. So now we can kind of see we have that first little flange. We've got the corner relief. We know we have enough clearance right there. And then I'm just going to kind of keep working my way along. So let's click on that edge and say flange. Just for fun, I'm going to start dragging that arrow. Let's look at it kind of from orthographic. Obviously that's not what we want, but I can kind of just drag this over and start to follow along. So 30 actually looks pretty good. And maybe for the height, I'm just going to say 10 millimeters in this case. I'll say OK. Zoom out just so you can kind of see what's going on here. And so I can pick that edge. I'll say flange. Look at it. Again, orthographic. Start to drag. Start to rotate. Looks like maybe around 20 degrees in this case, so let's do 20. And then, again, kind of keeping things similar, I'll say 10. Now what's really cool about this, I'm going to go ahead and say OK, is it matches pretty close, but you can see these are the 3 individual flanges, so I could come in and edit any of these at any time. So I could edit this particular feature and maybe change its angle slightly. You know, let's do maybe like 35 degrees. Say OK, and my downstream processes will update accordingly. So now it's kind of getting a little bit closer. So let's go ahead and edit maybe this feature and make that maybe more like 15 degrees. I'll say OK. And then maybe we change this guy. So again, I kind of mocked up what I wanted it to look like, and then I can come in and sort of tweak what I want this to final look like. So let's just say like 35 in that case. And we can kind of see what that looks like when it's all said and done. There we go. So you can always go in and edit those changes if you want to. Now I'm going to undo back, put it where it was so we're following the outline. So we'll leave it like this. Okay. Again, don't like sharp edges. So let me turn off the tube. Let's go ahead and fill it. And fill it. 10. That looks pretty good. Maybe that's a little bit too much. Let's do maybe like 8 millimeters. So yeah, you can kind of see if I went 10 millimeters, this would be an interesting test. It actually kind of goes into this little bend relief. So I like 10 millimeters. I'm going to say okay. Let's try and unfold and see if that works. What's my stationary entity? Let's pick a different one just to be different this time. We'll pick on that face. And sure enough, that unfolds, no problem. So that's okay. Now for aesthetics, maybe I wouldn't want to do that as much. Maybe I'd make it smaller, like 8 millimeters or whatever, but let's just leave that the way it is. Okay, looking through my outline here, making sure we're doing stuff. So I mentioned that I want to mirror some stuff over to the other side. Well, we're actually going to take it kind of to the next level. I'm going to put some holes in here, and then we're going to mirror everything over. So looking at this here, there's some holes here, and you'll see why here in a little bit in the next live stream. We're going to be there's going to be some legs that go through here, and they're bolted in, and there's a little push button that kind of holds them into place, and then you can rotate them, and that little push button goes into that slot. And so that's what we'll be doing on the next live stream of the miter saw. Okay, so I want to create some holes. Now, like I showed before, under the Create menu, you can see the hole command right here. So I'm going to say hole, and it's asking for a placement. I'm just going to pick somewhere on this face, like so. Then you'll notice it says reference. So what do I want to reference? Well, I want it to be a certain distance, maybe from like this outside edge or from this inside edge. You can see I can hover over. Well, I'm going to pick this outside edge, and I want that distance to be, according to the drawing, 33 over. You can kind of see it moved a little bit. And then you can see it's asking for kind of like the up-down reference. So I'm just going to pick maybe this bottom edge here, and we want it to be 10 millimeters from there. And you can see how it instantly updated. Then I need to specify what diameter I want that to be. I want it to be a 12 millimeter diameter. I want it to go all the way through the part, so you can kind of see it's going to go all the way through. We'll do a flat drill point, doesn't really matter. All I really care about is the size of the hole and where it's located. So I'm going to say OK. Now, some of you might have said, well, could you have done a sketch? I absolutely could have done a sketch. But I really like the hole command because it's so easy to come back and modify that compared to a sketch, I think. Another thing you can do, believe it or not, is I could come in here and say unfold all bends, and I can actually do like the hole command, create hole. I can even do it in this flat layout, like so. In fact, check out this really quick. I'm gonna save, just to show kind of the power behind Fusion. I'm gonna create a sketch. I'm digressing slightly here, I apologize. I like to show this. I'm gonna do a slot that goes across these features like so. I'll extrude those. We'll go all the way through. I'll say OK. And notice I did this while it's flat. Now I can click refold faces, and it's going to refold those faces and basically make that slot go around that corner correctly. It's pretty darn amazing. So, sorry for the digression there. Okay, so there's another hole. I'm going to come in here and say hole, kind of put it where I think it's supposed to be. Do the reference. I'm going to pick that same edge for the reference. This guy is 43 over. And from the bottom, I think he is like 65 up. You can kind of see that update. And then for the hole, this one is going to be 10 millimeters. So I'm going to say 10. Distance, I'll say all again, just making sure it goes all the way through that flange. Say OK, and there's my 2 hole features. Okay, this is where I think the magic happens. So some of you might be thinking, well, he could have created like half the trapezoid, done all this kind of stuff, and then mirrored the whole thing over. And I absolutely could have. But check this out. I'm going to say mirror. So create mirror. Now I don't want to mirror a component. I want to mirror features. In fact, I want to mirror that flange feature, and that flange feature, along with the fillet. So by selecting these 4 features, it's grabbing those 3 flanges and then the fillet, and then I'm going to say I want to mirror that hole and that hole. Okay? Now it's asking for a mirror plane, and you'll notice I don't have one right now. Well, if you remember from our last live stream, we actually did create one to put the tube onto the other side. So if I expand open my construction and I turn on that last plane, because I think it was one of the last things we did, you can see that it is slicing right through the middle of this. So I'm going to just turn that existing construction plane on and click on it. And you can see kind of a preview. It's kind of shaded a little bit. I'll say OK, and boom. Those are over there. Now, in other CAD systems that I came from, this would have killed the part. I would not have been able to unfold it. You literally had to pick one edge, pick the other edge, make the flange, pick another edge, make the flange. With Fusion, we just mirrored those features over. Obviously, I'm curious if it's going to unfold, so I'm going to come in here and say unfold, all bends, and check that out. That just blows me away that that actually works. So pretty cool. So instead of basically having to, pick this edge and then pick the edge over here and create the flange, I just did it on one side and it mirrored the holes. So if I were to change one of them, it would change both of them. So if I made that 20 millimeters in diameter, it's going to change it on the other side also. Give a thumbs up if you like that. So okay, let's see. Okay, so the last thing I want to do is because it's still sheet metal, there's I don't have it turned on. There's these little metal tabs in here, and I'm going to use sheet metal. Even though this looks like a simple extrusion, I'm going to use sheet metal for this, and you'll see why here in just a second. Okay, so I want to create a new sheet metal part. Now, if I were to say new component, it's going to put it under this leg support plate. So, which is, I think, fine because it's going to be all assembled together anyway. So I'm going to say new component. It's going to be a sheet metal. Let's call it leg tab. And notice now it says in this design, you were using this stainless steel millimeters. I still have the ability to pick something different, but it's just showing me what I currently am using. I'll go ahead and continue using that. And now you'll notice I have a new sheet metal component underneath this guy. Okay, I want to put this in a certain location, so I'm going to just create a quick sketch. Let's go ahead and maybe project. I want to project where this flange is because I want it to be a certain distance basically from this edge. So I'm going to click on that flange there. I also want to know, where it is from this bottom flange, and it's kind of hard to tell, but this is the fillet right here, and if I rotate slightly, sure enough, you can see that that's the fillet. So this is the flange right here. Okay, so I'm going to project maybe that guy and say, okay, just to give me some reference. Then I'm just going to draw a line, something like so. I'll say good. Dimension its length. So I want its length. I think I was pretty close. Yeah, 35. So I want the length to be 35. I want it to be parallel with that line there. So it's matching the same direction as that. And then finally, I want to put it in a certain location. So certain distance from that edge right there. So let's do, I think it was 45 according to the drawing, so I'm going to click that edge. I'll click on this edge here. I'll bring it down here like so you can kind of see it. I'll type in 45, you'll see the line move over, and then I want it to be a certain height off of that flange there, 32 millimeters, and we can see that that's now fully constrained. So I'm pretty much done. So basically what I did is I drew a line, but it's exactly where I need it to be because we're going to have a tube that's going to be between this tab. Okay, now when we first started, I had a trapezoidal profile that we made into a sheet metal part. Here I only have a line, but check this out. I'm going to say flange. I'm going to click on that line, and I'm just going to start to drag. Okay, so notice what it's doing. It's taking that line and it's creating a sheet metal part. Now I do want to be really careful. I want this tab to be on the other side of the line. So I'm going to switch this to side 2, because remember I dimensioned from this line to this edge to be like 45 millimeters. So I want to keep that. And then the tab length in this case is going to be 55 millimeters. I'll say OK. And I now have another little sheet metal part. I'm going to use the chamfer command. So I'm going to select both of these guys and say chamfer. Start to drag. So we can I'm going to rotate a little bit more isometrically so you can kind of see what this looks like. Let's make this 10 millimeters. And then I'm going to fillet these edges that were just created. So let's do fillet. And let's just do a small, maybe like a 5 millimeter fillet, so it kind of rounds those off a little bit, minimizes those sharp edges. Okay, the last thing I want to do is to create a hole for the bolt, and the bolt is going to be coming through this hole and into this tab. So what I'll do. Now you might actually, here's a good point. Some of you might be like, oh, you could use the hole command. Well, I don't know where to put that hole. So I'm going to click on a face and say create a sketch. And we're now looking at that face. There's a sketch on this angled face. I'll do P for project. And I'm just going to click on this hole right here. And you can see that it's where it's putting that hole on that tab. Okay. Now to me it doesn't look very centered, but that's how it looked on the other part there. So I just left it the way it was. I just took measurements. So I'll go ahead and say finish sketch. Now I have a location. Yes, I could do an extrude if I wanted to right now, but actually this hole in here is larger than that one. So I'm going to say create hole. And I'm just going to click on that point right there. And you can see it remembers my last setting, but it put the hole in that exact location. But according to the drawing, this guy is going to be an 11 millimeters instead of 10 millimeters. So you can kind of see the preview makes that a little bit larger. I'll say go through all. Now if I say all, notice what happened. Okay, so be aware of that. So this time I'm going to say go to a specific location. So I'm going to click on that face right there. Just a heads up. Or I could say through all and then turn off, you know, if I had said all, you'll see it highlights, but I could turn off the leg support plate and have it only go through the tab. So you have a couple different options there. So I'm going to just say go to this face. I'll say OK. And we now have that tab. Now, the fact that it's not centered bothers me a little bit. So I could come in here and maybe Oops, that's the wrong sketch. Come to this sketch here, and we could lower this, you know, maybe to like 31 millimeters or something. Try it out. Maybe it's even 30 millimeters. Actually, 31 looks good. So now it's more centered. Okay. And then the last thing is there's a handle that's going to come off of these parts right here. So I'm going to create these holes. Let's do that real quick. Actually, I'm done with the tab. So let's mirror the tab. Now here's what's interesting. I could say features, but instead I'm going to say components. And I'm just going to click on that tab, and it's going to grab that component. What's my mirror plane? That's my mirror plane. I'll say OK, and we now have the tab mirrored over. Hopefully you can kind of see how the bolt is going to go through the leg and it's going to pivot around this location. Okay, so the last thing is I want to modify this leg support plate, not the tab. So I'm going to activate the leg support plate. Here's all of the features that have to do with the leg support plate. Let's just create a quick sketch. Now, I'm going to create an actual sketch and a circle and all that kind of stuff and not use the hole command. Why? Well, with the hole command, because this is an angled edge, it can't really reference that edge. It's usually just a flat edge or a flat face that you can reference off of. So I'm actually going to create a sketch. In this case, let's make that 22. And I can dimension off very specific locations. So for example, maybe this corner right here. I want that to be 43. And I'm going to click that exact same corner and tell it to be 20 millimeters up. And we can see that that's constrained. Okay. Here comes some new functionality we just added in the last release. I want to show this to you. A really cool tip. You'll notice we've always had this construction line type. We now have this center line type. And I don't know if you've seen this before or played with it, but check out what you can do with this. I'm going to say line, change to center line, and I'm going to find the center right there, the midpoint. Find the midpoint right there. And you'll notice that the line type looks a little bit different. It looks like a center line, whereas a construction line is dashed like so. And you're like, okay, what's so special about that? Well, now I'm going to come in and say mirror. What's my object? This. And notice what happened. Fusion recognized you had a center line and it automatically selected that for me. In fact, let me cancel out. I'm going to go into mirror. And notice mirror line is already selected. So it found that and it's going to reflect that object automatically for me. So I didn't have to specify that line. So just another little tip, you know, for shortcut, speed things up. Kind of cool, I think. So, okay, got those guys. We will select these profiles. Actually, this is something interesting. I get this every once in a while. I'm trying to select a profile, and you'll notice as I'm moving my cursor, sometimes it highlights, sometimes it doesn't. And I see this in the forums quite often. They're like, I can't select my profile. Well, let's say that's the case. If you click and hold for about half a second, you can see it's going to select the sketch, the profile, the face, and then the face behind it. You're like basically probing through, and I can actually physically select the profile from that list. So again, I'm not selecting it over here. I'm going to click and hold, and I can grab that profile. So neat little trick, especially if your sketch is like on the back side of the sheet metal part, and you're like, oh, I don't want to have to rotate it around. You can probe right through. Okay. So let's do this. I'm going to say extrude. I'll start to drag. And again, I like to say all. I'm hoping that will work for me. Looks like it will. I'll cut, say OK, and we now have those holes going through. Oops, I need to hit OK. Going through the part. Okay. Last thing I want to show you, in the description of the video, I included a decal, or an image, I should say. And you can see it right here. It's called miter stand decal. So you can upload that into your project. What that'll allow you to do is now I can come in here and say insert a decal. And because it's in my project, it used to be you had to always insert it from your computer, but now you can insert it from a project. So I'm going to say that guy there. It's asking for a face. I'll click on this face here. And I'm going to kind of look at it from kind of straight on. And I can scale it up. I can move it around. So I can move it horizontally, maybe a little bit vertical, something like that. Say OK. Oh, and let me show you one more thing. Notice this chain faces. Let me show you what that does. So I'm going to drag this up, and you're going to see it's going to roll over onto those other faces. Pretty impressive. If I turn chain faces off, it's only going to show up on the one face. Now, why would I want to have that turned off? Let me show you. I'm going to go ahead and say OK, and let's look at it from the other side. And you'll notice I get some weird stuff going on because it's, I don't know why, it's a graphical thing. It's trying to chain it on the inside face, and it doesn't really know what to do there. So let's take a look at this guy here, decals. I can edit that decal. I'm going to turn off chain faces because it's only on one face. I don't need it to chain. And now you'll notice it looks much cleaner on the inside. And I point this out because I've actually seen this on the forums also, where people, like, they get a weird line and they don't know why. So I usually tell them just turn off chain faces if it's only on one face. Okay, so with that, we have made this part. The one last thing I'm going to do is unfold it to confirm. Boom, it works. So think about how difficult this would be to model normally without using like the sheet metal tools or something. Could you do it? You could, but it'd be pretty painful. So, okay. Hopefully you learned some new things. I referenced an existing live stream. I'll try and add that into the link of the video, where I kind of dive a little bit deeper, like creating your own custom materials for sheet metal. What does the inside, outside, tangent, and all that kind of stuff do. So I'll link that here probably within the next hour or so. So if you want to rewatch the video, you'll see that. With that, I want to thank Angelo. Actually, let me check the questions, see if there's any more. Let's see. So somebody said, often I get the problem when I open an existing project, I directly start working on it. When I forget to select the right component, can I transfer the individual features to the right component? That's a good question. You can't really transfer features per se, but you can move. So for example, I could grab this, this sheet metal part, and I'm just clicking and holding, and you can see I could move it into a totally different location. So I just dropped it into end cap assembly. So you can do that. Hopefully that answers your question. The other one was, oh, somebody asked during the part one presentation, I asked about unwrapping the fish mouth ends of the tubes to create a template. Will Brad be covering that today? The answer is no. So I don't know why. I don't want to get into too much detail here. There's machines that you basically use a hole saw to cut a pipe, and it creates that fish shape for you. If you wanted to create a template, you can do that. I'm not going to show it right now, but you would actually have to convert that pipe into a sheet metal part and unfold it. And you can do a search on YouTube for, I'm trying to think of what we best term here, but unfolding a sheet metal part. So yeah, I don't want to go into too much detail. Actually, it would take another 15 minutes. Maybe I will add that to my next live stream. But you would basically have to create a sliver slot through that pipe, and then add a little bit of an extra flat face, which would allow you to unfold it. And so again, that's why I don't want to go into too much detail there. So I will add that to my list, and maybe I'll show that next time. That's because that's kind of a cool ask. So with that, it looks like that was the extent of the questions. Angelo, thank you very much. I hope everybody learned something today, and we will see you on next week's live stream where Angelo will be continuing his Basics of CAM series. So we'll see you then. Thank you very much.